Good day, students. Welcome to mathcodeserve.com. And this clip we're going to be going over an example on how to apply the fundamental identities. So let's consider the following example. Okay, so let's assume that cosine theta is 7 over 9. So if cosine theta is equal to 7 over 9, the task is to find what cosecant theta is using the fundamental identities. Using the fundamental identities where theta is in quadrant 2. Okay, now you can solve this problem by using SOHCAHTOA and the Pythagorean theorem, but the constraint to this procedure is that you're required to make use of the fundamental identities. Now you have the fundamental identities provided for you to the right, all 23 of them. So we are to use one or more of these identities to determine what cosecant theta is, given the fact that cosine theta is 7 over 9. So the question is, which identity or group of identities can take us from cosine all the way to cosecant? Alright, you can think about it as a trip. You're taking a flight. So if you're flying from, let's say, cosine land to cosecant land, what flights will take you from this origin to this destination, considering the fact that these identities are your different flights? Is it going to be a direct flight? In that case, we just have one formula, or do we have multiple formulas or flights to take us from cosine to cosecant? Alright, so what we'll do is basically take a look at the identities we have here and ask ourselves, do we have any formula that has only cosine and cosecant in it? If we come up with any of those formulas, then that will be the direct connection between cosine and cosecant, and we can use that formula to accomplish our goal. Alright, so let's take a look at our identities here. We can immediately eliminate the even and odd identities and cofunction identities, since our angles are positive and we don't have any cofunctions here. Now, so we're going to look at, we can also eliminate the, well, we don't have to do that. We can take out the quotient identities, but let's look at reciprocal, quotient, and Pythagorean. If we look at the quotient identities, we have tan, sine, and cosine. We're just looking for cosecant and cosine, so none of them there. Here we have cosine, that doesn't work. And then here we have cosine and secant, and here we have cosine and sine. So we don't have any formulas that have only cosine and cosecant. So let's highlight the formulas that have cosine in them. So there goes the first one, cosine and secant in the reciprocal identities. And then this one has cosecant and sine. And then this one has cosine and secant. Well, these two are connected, so one of them will suffice. And then if we go to the quotient identities, cosine and secant, cosine and secant, none of them. This has 3, this has 3. Let's take a look at our Pythagorean identities. We have cosine and sine. And then we have cosecant and cotangent. So which of these identities can we use to go from cosine to cosecant? So if you think about it for a second, if you look at this identity right here, this Pythagorean identity, this can take you from cosine to sine. And if you look at this reciprocal identity, this can take you from sine to cosecant. So if we make use of the combination of this identity right here, the reciprocal and Pythagorean identity, then we will be able to accomplish our goal. Okay? So we can't have a direct connection. We need to make use of multiple. So what we're going to do first is go from cosine to sine using our Pythagorean identities, and then from sine we'll go to cosecant using the reciprocal identities. Okay, so let's delete the other ones. There are other ways to do it. There's another way to do it, but this is a pretty efficient approach. So the first step will be to go from cosine to sine using the Pythagorean identity sine square theta plus cosine square theta equals 1. That will take us from cosine theta to sine theta. And then from sine to cosecant, we're going to use the reciprocal identity where cosecant theta is equal to 1 over sine theta. Okay, so let's start with the first step, number 1. For step 1, we're going to find sine theta using cosine theta. The identity we're going to be using, let's rewrite it, is sine square theta plus cosine square theta equals 1. Now we know what cosine is. It's given in the problem. Cosine is 7 over 9. So we have sine square theta plus 7 over 9 square is equal to 1. Sine square theta. Now what is 7 over 9 square? When you're squaring 7 over 9, you're going to square both the numerator and the denominator. Okay, don't forget to do that. So we're going to have 49 as a result of squaring the numerator over 81 as a result of squaring the denominator. Now we want to get sine theta by itself, so we need to get rid of this fraction and then the square. So what we can do next is subtract 49 over 81 from both sides. On the left side, we'll have sine square theta equals, now write this as a fraction, 1 over 1. Then we need to find the LCD of 1 and 81. So multiply this by 81 top and bottom. Now that gives us 81 over 81 minus 49 over 81. So what is our sine square value going to be? Sine square theta is going to be 81 minus 49. 11 minus 9 is 2. 7 minus 4 is 3. So sine square theta is 32 over 81. Okay, now let's bring it back up here. Leave our workspace. So sine square theta is 32 over 81. Now to get sine by itself, what we'll do is we'll proceed to take the square root of both sides of our equation. So square root sine square theta, square root 32, and square root 81. Now anytime you take the square root of a square, you have to introduce plus or minus. So you have plus or minus root 32 divided by the square root of 81, which is 9. So guess what? We are halfway in our trip to cosecant land. We have gone from cosine all the way to sine. Okay, we now know what sine is. Sine is plus or minus root 32 over 9 depending on the quadrant that theta resides. We're going to leave the sign undetermined until we get to our final destination. So what do we do next? we're going to advance to step number 2, which is to determine cosecant using sine. So for 2, we're now going to find cosecant theta. Okay, so using the reciprocal identities that we identified earlier, we see that cosecant is 1 over sine. So let's write that down. Cosecant theta is equal to 1 over sine theta. So what we're going to do is substitute plus or minus root 32 over 9 into sine, and we're going to reciprocate. Okay, so if you want to save time, you can simply reciprocate that. Well, let me show you the work. We have 1 over plus or minus root 32 over 9. This complex fraction can be written as the numerator times the reciprocal of the denominator. You drop, change, flip. Okay? And then when you multiply that out, you have cosecant theta equals plus or minus 9 over root 32. Okay, now, you may not have a radical in the denominator, so let's go ahead and rationalize this radical denominator out. So we have root 32 times root 32, and that leaves us with plus or minus 9 root 32 over 32. Okay, next question, can we reduce root 32? Let's go ahead and do that. See if we can break it down. Root 32. Let's extract prime factors. 2 goes into 32 16 times. And then 16 is a perfect square, right? Because when you root 16, you get 4. So 16 basically comes out of a square root as a 4. So root 16 comes out as a 4. And this 2 stays behind because it's not a perfect square. So root 32 is basically root 2 times root 16, which reduces to 4 rad 2. So how do we insert that here? Well, we put in the simplified form of root 32. So we have plus or minus 9 multiplied by 4 rad 2. And that is divided by 32. Okay? Now let's see if we can simplify. 4 goes here once. 4 goes into 32 8 times. So cosecant theta in its reduced form is either positive or negative 9 rad 2 over 8. So the question now is this cosecant theta value positive or negative? We're told in the problem right at the onset that theta resides in quadrant number 2. Okay? So what does that mean? Well, it means that we can basically use the location of theta on the unit circle to determine the sign of cosecant. Okay, so we remember that all students take calculus. We are in quadrant number 2. So the question is, what is the sign of cosecant in quadrant 2? This S means that sine and its reciprocal cosecant are positive. Okay? So what are we looking at? We're looking at cosecant, which is the reciprocal of sine, and that automatically follows that cosecant is positive. So our final answer, cosecant theta, is positive 9 rad 2 over 8. Okay? So there goes your final result. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your study of the fundamental identities, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this tutorial or on the process of applying the fundamental identities in general, just place your question in the comment section below and we'll be glad to support you. We update videos to our YouTube page on a consistent basis, so do subscribe to our channel so you can get updates to those uploads. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.